Hi dear friends, and welcome to this session today. And please, I want us to verify if the square root of the second derivative is the same like the derivative of that function. So please just drop a comment down below if you think this is correct or not. Okay, yes, just drop a comment down below. But in our general case, we should know that this statement is not always true. Okay, the square root of the second derivative is not always the same as the derivative itself. Okay, but we can somehow find a certain function which this statement is true. Okay, we can somehow get a certain function, we can call that y, for which this statement is true. Yeah, so that's the main objective of this video. So I want us to just dive straight into it. And please, just for a quick, if you're new to our channel, please just hit the subscribe button and press the notification icon such that each time we upload videos, you can be the first person to be notified. And please give this video a like. That's the most important. Just give this video a like, because that does motivate us a lot to produce more and more content for you. And thank you very much. And please follow our Facebook page, because we are going to put the link in the description for your convenience. Okay, because there are so many interesting materials there that are going to be so beneficial to you, and you can't afford to lose them. Okay, yeah, so thank you for subscribing, thank you for liking, thank you for following our Facebook page, and let's dive straight into it. So I want us to, like I said, get a certain function y for which this statement is possible. So I just want us to solve, because if I square this equation, if I just square it, I'm simply just going to have the squared y ordered on the x squared. That has to give us what? Dy by the x, all that squared. Great. But please keep in mind that the second derivative is just the same like what? The derivative of the first derivative. This is what I'm talking about. We can express the second derivative as d by the x into what? The first derivative, that's dy by the x. Great. Which is the same like dy by the x, all that squared. Perfect. So in this case now, I can just do a substitution. I can take u, let my u equal to what? My dy by the x. Okay, great. I can let u equals what? Equals dy by the x, such that in this equation now, this equation simply translates into d by the x into what is dy by the x? It is what? My u into u, which has to be the same like what? Dy by the x is what? U. So it's going to be u, all that squared. Great. So I see that I have, this is a differential equation, right? And it's separable. So I can separate the differential equation now and solve. That implies I'm going to multiply all through by the x and divide all through by u squared. So in this case, I'm just going to have my du. I'm going to have my du, all that on u squared, which is the same like what? My dx. Good, cool. So that's exactly what I have. So in this case now, I have a differential equation which has been separated already. So in this case now, all I have to do is just to integrate all through. So I'm going to have my if I integrate dx, I simply have what? X, right? X, which is the same as, I can say x plus a constant. I can call that constant c prime, which is the same as, if you integrate du over u squared, I simply have what? I simply have -1 over u, okay, plus another constant. I can call that constant c prime. Okay, yeah, because each time you integrate, don't forget to add a constant. So but I see that since in this case I have x, then I have plus c prime, which is the same like -1 over u plus what? C double prime. If I subtract, let's say if I subtract c prime on both sides, I'm just going to have what? I'm just going to have my x, which is the same as what? As -1 over u plus c double prime minus c prime. But I know that c double prime is a constant. Likewise, c prime is a constant. So a constant minus a constant is still what? A constant. So I can just replace c prime minus c. I can replace c prime minus c prime by just what? A certain constant. I can call that constant c. So that implies this equation now translates into x, which is the same like what? -1 over u plus what? Plus just a certain constant c, right? Cool. So in this case now, I will make u the subject. By making u the subject, I'll simply bring c, I'll bring c to the left hand side such that I'm going to have x minus c, which has to be what? Negative 1 over u. Great. So in this case now, I'll multiply all through by this negative sign. That implies I have 1 over u, which turns out to be what? Which turns out to be negative x. Wait, negative x now plus just my constant c, right? So in this case now, I'm solving for u, so I'll just take the reciprocal on both sides. Because here's 1 over u, I'll just take the reciprocal on both sides such that I'm just going to have my u to be equal to what? 1 over negative x plus c, right? Cool. Now, remember, I am to find a function in terms of what? Y, but in this case, I have just u. But I'll look back into where I made this statement that let my u equals 1 my dy by dx. So I'll just replace it back in this place. I'm going to have my dy by dx. That's I've replaced it with this u, which is the same as what? 1 ordered on negative x plus c. Perfect. So in this case now, I'm going to still separate my variables because it is in a form in which I can separate the variables. So if I separate the variables by multiplying all through by the x, I'm simply going to have what? Going to have my dy, which has to be equal to what? 1 over negative x plus c, then dx. So in this case now, I can therefore integrate all through as well. If I integrate all through, if I integrate dy, I just have what? I just have my y, which is the same as, if I integrate 1 ordered on negative x plus c, keep in mind that negative x plus c is what? It's a linear factor, right? It's a linear function. So I'm simply just going to have natural log of what? The absolute value of negative x plus c, right? Cool. But don't forget the reverse chain rule. One of the chain rule says we divide by the derivative of the input. The derivative of negative x plus c simply gives what? Negative 1. So if I divide by it, I'm simply just going to have a negative sign here, right? Cool. Then I'm done integrating. I'll just put a certain constant plus c1, right? Great. So this function can translate into my y equal to what? Equal to negative natural log of the absolute value of negative x plus c, all that plus what? Plus I can call this guy now c. I can call it c prime. Yes, cool. So this is a function in which if you differentiate it twice, that is, if you differentiate this function y equal to negative of the natural log of negative x plus c prime, if you differentiate it twice, it will be the same as the square of the first derivative. So thank you guys for watching, and please subscribe to my channel if you've not done so, and like this video because it does motivate me to produce more content. And please follow my Facebook page. The link, like I said, will be in the description for your convenience. The next video, you can only watch the next video if and only if you've subscribed to the channel. So please just go ahead and hit the subscribe button such that you won't miss on any video we upload. Thank you.